Welcome, I'm Bill Wake. This is my summary of the week's work on Twitch. We've been working on a word game called Betwist. The idea is you're trying to find words in a grid of letters, and the grid wraps around, and we're visualizing that by allowing an infinite scrolling across the board. So you'll see in the picture on the left, you can see the word Sears is highlighted, and you can see that it's got those letters highlighted elsewhere too because the board repeats. So this past week, we introduced that infinite scrolling. Before, we had something that would relocate the column from one side to the other, or the row from top to bottom, to simulate that rotation. But now we have this notion of infinite scrolling. We introduced scoring, and we did improvements in the top level view, which also has a challenge that we'll address next week. Our approach to infinite scrolling, we have a notion of border views, that yellow square in the middle, or the big yellow square. And that's really sort of a tic-tac-toe board of 9 copies of the main view. Well, the main one is the green one in the middle, and then 8 copies surrounding it. We have the notion of a viewport that looks at the main view and maybe some context around it. And we have the core view, I called it here. And we have the center of the viewport is that dot. And so the way we're going to approach this is whenever you're scrolling, make sure the dot stays inside the core view. So this one's okay because the dot is in the green. So we've moved the viewport. We can see some of the surrounding views on the left and bottom, and we can see part of the original view. And same thing here. We've got the center of the viewport is still in the green. Now, if we did this, the center of the viewport is outside the green. We're still seeing some green, but the center is not in the right place. And so something like this, where we hit the edge of the screen, is really right out. We don't want that at all. So our approach is we're going to take, anytime we move, if it would put us outside the right range, we'll translate the viewport back to the core cell, and it's fine. So that keeps us working. It keeps the view always partly on the green, and that's what we want. Let's see a demo. All right, so here I've highlighted the word Sears, and we can scroll around. And notice let me grab the center of the queue. You can see it's there. We've got the original board here. This one was the original. Now I'm on the other board, and when we hit that edge, we're just going to keep scrolling. We're wrapping, so it keeps the illusion that you've got an infinite board, even though there's only 9 copies. Now, we tried this on iPad, which we hadn't really done before, and it turns out 9 copies is not enough because the iPad screen is so big relative to the phone. We'll figure something out for that. It may be 16 copies instead of 9 might do it, or we'll find some other way. The other thing we added, we've added the notion of a score. So I'm going to hit this, and you'll see this go down, and the score will update. So Sears has 5 letters, and that's our biggest word. Now you'll notice it gave us credit for 2 words because we take the prefixes of words. So if you have Sears, we give you credit for seer as well. So that's why it's 2 words and 9 letters, the 5 and then the 4 for seer. It's not the final scoring approach, but I think knowing how many words you guessed, how many letters you guessed, and the biggest word, that's our scoring for now. Eventually, I'd like to have this in a sort of leaderboard kind of thing that, your top 10 scores or something like that. I'm not sure quite how we'll assess those, but I think having big words is kind of a key part of it. So, and I don't see a lot here. I don't know if quote. Yeah, and see, I can bounce around. Okay, around the corner. All right, so quote. We might do better. Quote. Terse. Yeah. Okay, so we got a 7-letter word now. We did something last week to show us all the words on a board, and I guarantee there are longer words and more seven-letter words than I'm seeing here, but that's the way it goes. Then the last thing we have is we added the score, and well, actually, we did it in the other order. We added the score, and then we said, I'd like to make this go end to end. So before it was a little stained glass square in the middle, showing just it had just enough room for the main board and part of the surrounding context, so you might get a sense that you could scroll. But I thought it might look nicer to go all the way across, and so to do that, we have to use what's called Geometry Reader. Geometry Reader attaches, and then it can tell you things like what's the size of this view or what's the size of the screen. So we needed to find out the size of the screen so we could know how far to make it across and also down. But there's something funny going on with it, and it turns out that Geometry Reader assumes that it should just take over the rest of the screen. And so it's kind of pushing in some extra space here. And so the score, we kind of had to tweak it a bit so that the score showed up at all. But left to itself, it would show up in here overlapping some of this. So there's kind of a conflict between what the view for this thinks it has and what the Geometry Reader thinks it has. And we ran into another problem with that we had the score on the left and the list of previous guesses on the right, which I still intend to show you something. But there's some interaction between the way the horizontal stack, the row of these things, interacts with the Geometry Reader and the view. So to simplify it, I took out the word list, which we'll figure out a way to put back. I think I'm just going to show you the last couple of words and maybe a more button to let you see the whole list. Yeah, it might. Yeah, I think that'll do it. And that once we get that straightened out, we'll I think what will work is to put the whole board in one Geometry Reader. And then it doesn't have it's already taking up the whole screen, so we don't care that it does. And then there's some little dance you have to do to pass that information about the size down to the particular views, and we'll go through that. So something for next week. All right, let's take a look at the code, and we'll start with this infinite grid. So the core of this is this grid view, and this is basically one copy of the grid, attached to the game, and it knows how to collect the word you guess. Okay. And so the tic-tac-toe board is 3 by 3. So 3 rows of 3 columns and one copy of grid view in each. And that gives us that border view, the yellow cells on the outside and the green grid in the middle. Okay. It's not green when you see it, but that's the way I think of it. Okay, and then the way we're doing scrolling, well, let's go down to this. We have the notion of a drag gesture, and that's kind of a built-in facility. We tell it the minimum distance. If you move your finger 4 pixels, you're dragging a little bit. Okay, treat that as a drag. And what we do is we track the offset, and the drag info gives us how far have you moved from your starting point, and we capture the prior offset basically before we get started. So the current offset is going to be the original offset plus the dragged offset. And so width and height will reflect that. Now notice offset is sort of the temporary version. And once we have that width and height, we're going to do a wrap. And wrap says, take this size, okay, which is the game size, the number of cells in our board is 5 by 5, times the cell size, each one's 50 pixels. And so we have, in this case, 5 times 50, 250 pixels. And we're going to wrap by that. So it always gets put in the range. Basically it's zero centered. So 250 centered around 0 is minus 125 to plus 125. Okay, so the board always gets wrapped in that range, and that keeps the central board in range. If we try to drag off the edge, it puts the center board back in place. And then when you end your drag, that's when we capture the prior offset. So next time you're starting from the previous place you dragged to. It's somewhere in the central board, but it's reflecting where you left off. Okay, if we didn't do this, every time you dragged, you would start from the centered board, and that wouldn't be very good. Okay, so let's look at the wrapping, and that's this offset. Okay, and the offset knows basically it has width and height. Okay, and so wrapping this thing to the size, the wrap size, is really just wrapping each of width and height because we're dealing with a square. All right, and so we made an extension for float, or CG float, to do that. And so he's zero centered around some amount. And the boundary for that, basically we're going to do the zero centering. We're going to take half of the boundary, the wrap amount. So if it was 250, we get to 125, and then value less than minus boundary is minus 125, and boundary is plus 125. So if it's too small, we're going to keep adding our wrap value until it gets in range of, it's bigger than the negative boundary. If it's too big, we're going to subtract the wrap value so it stays inside the boundary. So in the end, you have something that's between the low and the high. Okay, and we pulled this out because we took an initial swipe at those measurements and thought, oh, it's straightforward, we'll just do it. And it turned out to be relatively complicated to keep track of the where things were and how the wrapping worked and all that stuff. And we went through about 3 or 4 theories of how it should be, and then said, well, I guess 2 or 3, and then said, okay, we're going to TDD it, and had the theory about the dot staying in the middle and so on. So that it was a little clumsy to get there, but I think knowing this wrapping and the way it works, I'm much more confident now. And visually, you could feel the difference because we were seeing stuff that would be off. You'd grab this part of a letter, and then you'd start dragging, and you'd end up dragging from some other letter and things like that. And it was kind of like paying attention to that prior offset to know when you were zero based and understanding what the translation from the drag info really was and all that. Okay, now something easier was the scoring. All right, so we basically defined this notion of what things do we want to be in the score: the word count, the letter count, and the most letters. And we have just a little data bag kind of object to hold that. Now, the actual computation of those things is in guesses. Guesses is your list of all the words you guessed plus all the prefixes we gave you credit for. And so the core of it right now is just a list of strings, and one for each word. And so the word count is just the number of words in that array. The letter count, we're going to do a reduce, which is sort of like summing across them. So we're starting with 0, and then we're adding the count of each word. So the next is really a word. I probably could use that word. It might be more clear. Okay, so you've got your sum so far and the word, and it just goes through the list and adds up all the word counts. And then the most letters also walks through the list. It changes each word to its count and then takes the max. And if you don't have any, it just returns 0. So I could imagine a score that doesn't involve the guesses object, maybe, like maybe the number of turns should affect your score, or, your hit ratio of how many wrong words did you guess, or something, that's not in this structure per se, but for now, this one has all the answers, and the game, when you ask for the score, the game object goes to the guesses and fills in a score object, and that gets passed back to the view. It's looking at a score, and it just puts a title and the 3 values that you saw on screen. So that part was pretty easy. Okay. And then that last bit about the geometry reader and all that, I, we're gonna rework that. But so coming up next week, then we're gonna do that rework of geometry reader, because of it thinking it should get the rest of the space. Okay. Then we're gonna do some work on the list of answers. I'd like to have it so that when you open the view that shows you the full list, you get all the answers kind of sorted by length, descending, and we'd like to see, here's your 8-letter words and your 5-letter words and so on. And then also we add those prefix words for free. So I did seers and I got seer. I'd like to have some indication that those words were added by the system instead of added by the user guessing. All right. And just to kind of, let you see what you really accomplished, I guess. And then we need to do something to deal with a new game. I also want to be able to support different sizes of games and some other things. So if we get far enough, we'll work on that as well. All right, if you'd like to join us, it's Monday through Thursday, 2 to 4:30 Eastern Time or 6 to 8:30 p.m. UTC. xb123.com/Twitch gets you to the live session or Twitch's old copies. And then xp123.com/YouTube takes you to the old sessions. They're time delayed by about a week or two and lightly edited. Hope you can join us sometime, and thanks for watching. Bye-bye.